Another video for the channel. It's been a little while. It's spring break, so the kids are out of school and doing a little vacationing and taking care of them and working on a side project. I wasn't working on the car. I was working on something to work on the car. I was building a tool. I managed to run I snapped off a drill bit and ran the stub of it through my finger. I got 4 stitches in that finger, so I've kind of been relegated to light duty work. I haven't been in the garage working on the car, but I have been working on the car inside with the laptop. I don't know if I've talked about it on the YouTube channel, but one of my real goals is to get rid of the factory dash and go with a completely digital dash, some form of tablet, probably an Android or a Windows 10 tablet running in the dash, probably an Android tablet, because I definitely don't want to rely on microshaft for anything in my car. There's lots of apps that you can download for your tablets, Android or iPads, that will, I'm sorry about that, guys, a bug flew over the camera, that will talk Canbus or ODB2 to a car ECU and display the data on the tablet. I've tried several of them. There's one called RealDash I really like. I think I want to use. I've been testing it in my truck, and it works great. Problem is it won't work with the Subaru ECU, because the Subaru ECU does not talk native CAN bus or ODB2. It talks SSM, which is a protocol that very few companies use. It was really ahead of its time when it came out, but once the industry standardized on ODB2, it kind of fell by the wayside, and Subaru held on to it probably a little longer than they should. Starting, I think, somewhere around 2010 or 2014, they went native Canbus ODB2, but for these early 2000s ECUs like I've got, you got to talk SSM. So unless I wanted to change the ECU, which I actually did want to do, I wanted to change it out for an aftermarket one that didn't have an immobilizer on it, but there's issues with getting it tested. I could have easily gotten it registered and bypassed the emissions here in Texas, but then if I ever went to sell the car and somebody was like in California or New Jersey, they might not have been able to register the car without the factory ECU and the emissions testing that goes on with it. So I kept the factory ECU. It talks SSM, so I've got to find a way, if I want to get rid of the gauge pack, to convert that SSM into native CAN bus. And so I've decided to do that with an Arduino for several reasons. One of them is I'm already going to have an Arduino to control the electric parking brakes that are back here. Also, if I have an Arduino, I can bring in additional analog and discrete inputs that aren't already in the ECU, like the blinkers. And the blinkers, trying to tie those into the ECU is actually how I fried that my original ECU, was trying to bring the blinkers into it. So using an Arduino, I can bring in the blinkers, I can bring in oil pressure, which the factory ECU doesn't have. I can bring in fuel level, cruise control, all kinds of stuff that's not in the factory ECU. I can bring all that in to the Arduino and inject it into the CAN bus stream along with the data that's already in the ECU. So this is a little test board I had set up. There's my old ECU that I smoked. It wouldn't run a car, but it would turn on and you could get some values out of it. And I use that for the initial testing. And so now that I'm kind of through with that, that's actually all disconnected. I'm actually talking to the real car now, or the ECU that's not smoked and hooked up to a car. What I've got is pretty basic. It's an Arduino Uno. And then I'm using this, I believe it's an MCC 60165, but I'll double check that and put a link in the description for anybody who's interested in that. The one I got from Mouser was that little bitty teeny tiny black chip, and then I had to solder it onto the SIOC adapter. And then the pin numbers are actually printed on that little black square, and you can't see them with your naked eye. The only way I could see them was to take a picture zoomed in with my phone. But the pinout, it's really, once you figure out what the pinout is, it's fairly simple. You need power and ground back to the chassis, to the car, power and ground. So I've got some temporary wires, red and blue, for power and ground here. So on one side of it is all the car communication. So you've got power and ground and the K line, which is the SSM communications, and a resistor, which it shows you in the data sheet for the chip that you need the resistor. And then the other side is just back to the Arduino. It's just power and ground, and then 2 wires for the serial communication between the chip and the Arduino. I've got a thread going on the 818 forum that's got wiring diagrams for all of this. I'll try to put that in the link as well. Well, I'll put that link in the description, and if you follow it, you'll find the link to the chip and all the other stuff that's going on there. So this basically is a SSM to serial converter is what that chip does. So that chip talks SSM. If you follow that green wire out, it changes color several times because I just daisy chained some little wires together, and then it goes into ODB2 port and talks SSM, and then it converts it to serial back to the Uno. And then the Uno is through the USB port talking serial back to my laptop. It can't communicate right now. It should be getting, well, it froze the values at the last spot because my code is kind of temporary. It's not really set to optimize. It's not optimized. This is very proof of concept right now. So I'll crank the car up in a minute. It'll get loud. It'll be hard to hear me, but you'll be able to see the values start updating. I gotta go get the key first. It's the one problem with this keyless, no touch, just approach the car system, the key guard I installed, is that if you got the key in your pocket and you're standing near the car, it's constantly clicking and cycling, so have to set it down. The RPMs are running about, I don't know, 1400. 1361. You can see the coolant temperature 114. Some of these values are not working. I've certainly got some things I've got to work on. They're giving me, I know the absolute pressure is not 5. The timing advance is not negative 64. So I've still got some troubleshooting to do. But it's definitely communicating. I can rev the engine up and down, and the RPMs follow, so I know I'm in good shape there. So the next step is to get all the mappings and scalings figured out and make sure all the values read properly. And then I've got to get it from there over to wherever I'm going to send it, a laptop or an iPad or an Android. For now, I'm going to do it on my laptop. I can get the program on my laptop. And I have tested that program from the Arduino to the program, and it works fine over the USB port, but I can't get it to work over the software serial port. So that's what I'm going to be troubleshooting next, is getting it to work over the software serial port so that I don't have to have a USB. I actually want to have a Bluetooth or a Wi-Fi connection. So I had if you look at my thread, I've got a Canbus chip that I was intending to use, and I was going to run, SSM into the Uno, and then out of the Uno through the serial to Canbus Convertor chip, which is an MCP 2515, and use that and inject it into the ODB2 port. But I'm having a lot of trouble getting that Canbus port to talk, and the program I want to use, RealDash, supports direct serial communication, so I can just put a Wi-Fi or Bluetooth to serial port or adapter on this board and talk directly to it, and it'll still support 115 kbps, which is plenty sufficient for the communications I need for a dash. So I'm probably going to do that and skip the MCP 2515, but I'm not 100% positive. That'll probably be the next video. Thanks to the hysteria around the coronavirus, kids are out of school for the next 2 weeks, so I'll be at home for the next 2 weeks. Obviously won't be flying anywhere, so I'll have plenty of time to work on this, and I hope to completely have this solution wrapped up by the end of the week before I get my stitches out, so that once I get my stitches out, this is done and I can get back in the garage and start doing manual labor on the car. Back to working on the digital dashboard. As you can see, I've got a little bit of lag I got to figure out how to deal with, but temperatures are reading, RPMs are reading, odometer's still not reading correctly, battery and AFR are reading correctly, fuel's not reading correctly, so fuel and odometer don't seem to be working. Everything else seems to be working. Oh, and boost isn't working. They're reading in the Arduino, so it's a mapping issue between the Arduino and the RealDash software. So real quick recap. That's the MCC3660. It converts software serial on the Arduino into SSM talking to the Subaru. So it's got chassis power, chassis ground, and K-line coming from the car. K-line is the SSM, and then it's got power, ground, and transmit and receive coming from the Arduino. Reads everything in, and then it's all going out via Bluetooth. That's a Bluetooth module, so the little phone here is connected to that Bluetooth device, and then so all the data comes in through here into the Arduino and then out through the Bluetooth to the tablet. And Bluetooth is supposed to be plenty fast enough, so I don't think it's an issue with the Bluetooth itself as far as why I'm seeing a lag with the RPMs. Probably a code issue. I got to make sure I don't have any delays in there. I got to see how fast I can bump the communications on the Bluetooth chip up. It's only at 9600 baud right now, but the ECU only reads at 4800 baud, so I'm still twice as fast as the ECU can talk. So gotta do a little playing with it, but I'm really excited. I've been marooned, stuck at the house for almost 2 weeks now. Everybody hunkered down because of the coronavirus. So and I got the stitches in my thumb out today, but while I was unable to work in the garage, I've been trying to hammer out this code, and I'm real close. So figure out a little bit of delay, figure out the mapping issues with the boost, the odometer, and the fuel, and then figure out how to wire in some analog inputs to the Arduino. I'm going to bring oil pressure into Arduino, and then discreetly I'm going to bring in the blinkers and the high beam so that I can show the blinkers in the high beam. And obviously this phone is just for testing. It's the only Android device I had around. It's an old Samsung. I'm going to buy a big tablet that'll fill up pretty much the entire area of the dash. So yeah, it's probably gonna wrap up the videos on this. I may show the finished product in a later video talking about the interior, but in the comments of or the description for this video, I'll link the forum thread where you can get all the wiring diagrams and code that's making all this work.